In section 8.4, we're starting to deal with something called binomial probability. Now, in a binomial distribution, or binomial probability, what happens is we repeat the same experiment a fixed number of times. Generally, we say there's n trials. Each of those trials has either a success or a failure, so there's kind of only two different possible outcomes. And then each time we repeat the trial, the probability of a success is the same every single time. It's a probability of p. In a really basic case, you could look at this as maybe the probability of getting a certain number of heads when flipping a coin a bunch of times. That would be a probability of 0.5 every single time, but it doesn't have to be it doesn't have to be the same chance of success as it is failure. It could be maybe you're rolling a die and a success is getting a 6, in which case your probability of success would be 1/6. Your success, like I said, is rolling a 6, and then your n, the number of trials you have, is just the number of times you roll the die. So let's look at some examples here. You can see the first example, it's rolling a die 3 times. What is the probability that it comes up as a 4 exactly once? So whenever you're dealing with a binomial probability, the best place to start with, well, first off, to note that it's a binomial probability. You know, we have the hallmarks here. We have repeated trials, so we have something that we're doing the exact same time multiple times, and we're counting a number of successes. Now, this idea of successes, this may seem a little bit twisted in certain cases, but the success is not saying necessarily something good happening. It's just whatever we define a success to be. So in this problem, we actually need to define what our success is. And since we're counting the number of times it comes up a 4, that's what I'm going to define a success as. So getting a 4. So if we wanted to use the formula to calculate this, we'd need to figure out n, the number of trials. Well, we're rolling the die 3 times, so there are 3 separate trials. We need p, which is the probability of a success. A success is just getting a 4, and that's 1 out of 6 because there's only one 4 on the die. I'm assuming that this is a 6-sided die. And then x is generally the third variable that we're going to be using. And you can see that's in the formula up here. This is the number of successes that we're talking about getting, and since we're talking about getting exactly 1 4, that means getting a success exactly once. So n is 3, p is 1/6, x is 1. So if you were computing this thing by hand, using this formula, you can see it's n choose x times p to the x, 1 minus p to the n minus x. Let me just walk through the formula. You're not generally going to be using this formula. You can plug stuff into your calculator, but at least to see where it comes from, I'm going to do it a couple of times. So 3 choose 1, so from our three trials, the success could have been any one of them. We're essentially picking a sample of one of those trials. P to the x, that's 1/6 to the 1. So the probability that this is that we get a 4 exactly once. But if we get a 4 exactly once, that means we also have to get 1 minus p, that's 5/6. That's getting the probability of getting something other than a 4, the remaining 2 times. So you can see the 3 parts of this formula. 3 choose 1. That's our combination. That's basically, this could be any of the 3 different. It could be the first, second, or third die that we rolled. The probability of a success is 1 out of 6 to the first, and the probability of 2 failures is 5 out of 6 squared. That's just using the multiplication principle to multiply those, and then counting them up using the, well, I guess, is that the multiplication principle? Whatever. What is the probability that it comes up as a 4 exactly twice? So in this instance, we're still using the same n, the same p, but we're saying we want it to come up at 4 exactly twice, so we want 2 successes. And how that's going to impact this formula, 3 choose 2 times 1/6 squared, because we get a 4 exactly twice, 5/6 to the first. There's only 1 failure. As far as plugging those into the calculator, I'm going to pull up my VI calculator here. I meant my TI calculator. Alright, so to calculate these you have a couple of different ways you can do it. You could just type in exactly this formula. 3 choose 1 is 3. 1/6 to the first, that's 1/6. 5/6 squared, you could do 5/6. And then raise it to the second power, or hit squared here. You can see we get a probability of 0.347 on this calculator. But there's actually a specialized function. This is approximately 0.347. There actually is a specialized function on this calculator that allows us to not have to remember this whole formula. It's called a binomial PDF. So to get to it on the TI 89 or 83 calculator rather, or the graphing calculators in general, you'll press second and then you'll go into distributions. So you can see here in yellow it says DISTR, that's for distributions. And then I'm going to, you can either scroll way down, or it's sometimes easier if you're right at the very top, you just scroll up a few times to get to binomial PDF. On my calculator you can see it's at entry 0. We want the PDF, not the CDF. I'll describe what the difference is between those in a little bit, but not right now. So binomial PDF, we'll press enter, then we'll do NPX in the exact order that I wrote them here. So N, and you do commas between these. This button right here above the 7, that's a comma, so you'll press that button. Then you'll do 1/6 for the probability, so 1/6, then comma, 1, close up your parentheses, hit enter, and you can see we get the same number as we got just right above. So we can do this other one. On this one we have the same N and the same P. So I'm going to press second and then enter to pull up my previous entry, and I'm just going to scroll back a few characters. I want to just change my X to 2. And that's the only change I need to make, so I'll just do that. Press enter, and you can see we get a probability of 0.069. Now, I have that explained a little bit here. On the graphing calculator, you'll hit second distribution, scroll up or down to find the function. On the TI-36X Pro, I don't have an emulator to show you guys what it will look like. I'll try to find a video and put that so you can watch the video of somebody using this, but it seems like people are always using different methods for calculating the binomial on the TI-36X Pro. In any case, it's very similar, except the distributions menu, you have to press second, and then there's a button that says statreg / distributions, or DISTR. That's the button you'll press, and then there are two, when you go in there, there's going to be two tabs. There's a statreg tab and a distributions tab. You're just going to want to press the right arrow to go over to the distributions tab. And then you're going to scroll up and down to find the binomial PDF. We're going to be using the same method to find the binomial CDF once we come to that. So just remember how to get in there. And actually we're going to be using this distributions menu, this menu right here. Looks like I'm crossing it out. We're going to be using this distributions menu on both of these calculators for a few other functions. So this is definitely one menu you're going to get used to going into. On the TI-36X Pro, once you've gotten once you select the binomial PDF, it will give you prompts for entering your N, your P, and your X. So it kind of walks you through that process. You hit calc, and then you should get the same number as what we got before.